In podcast 27, we're going to look at energy sources, where we get our energy from, the different types of energy that these energy sources have, and how when energy is transferred, we always lose some, leading to the idea of efficiency. So we always use, or we have to use, a lot of energy to get work done in our lives. And the energy we use comes from many different sources and is available to us as different types. To get best use of the energy sources we have, we need to convert them into useful forms of energy. For example, coal in itself is not that useful to us, but when we convert it in a power station into electricity, that's useful. When we convert energy from one form to another, more useful form, we always lose some of that energy. So when we transfer energy, we haven't got a 100% efficient situation. We always lose some. So let's look at the different forms of energy that we have. So we have potential energy, energy which is stored up and not really doing anything. Gravitational potential energy, things that are above a certain level or above the ground, like a lake of water used to generate hydroelectricity. Elastic energy, a stretched elastic band or a stretched bow ready to fire an arrow has elastic potential energy. Chemical potential energy, anything that we can burn or eat in general will have chemical potential energy. It's energy stored in the bonds between atoms and molecules. And nuclear potential energy, when we break nuclei up or maybe stick nuclei together, we can release nuclear energy, like in a nuclear power station or nuclear weapons. Kinetic energy, the energy of motion. Heat or thermal energy. Light, or more generally electromagnetic energy or solar energy. Sound energy, or again more generally vibration of particles. And electrical energy. So these are the forms or types of energy that we have available to us. And these forms of energy are present, if you like, in the energy sources that we can find around our planet. Energy sources such as food, the most important energy source to us as humans, which has chemical potential energy. When we eat it, the chemical bonds are changed and it releases energy for us. Crude oil, we drill into the ground, the oil comes out. It's a product of fossilized, if you like, organisms from a long time ago. And again, we can burn crude oil, releasing the energy, so it has chemical potential energy. The sun is a major source of energy for our planet, and we would say that that has solar energy or electromagnetic energy. Coal, again, dug up, ancient trees. We burn the coal, we release the chemical potential energy that's stored inside. Natural gas, again, a fossil product created after many millions of years. We burn it, releasing the chemical potential energy. Wind, moving air, has moving energy, kinetic energy. Wood and plants that we might burn, again, chemical potential energy. Geothermal energy, the inside of the earth is hot. It has a lot of heat energy there. We can tap into that. And water. Water, when it's elevated above the ground, high up in a mountain lake, if it's allowed to flow down, then the gravitational potential energy that the water had can easily be converted into moving energy. So these are some of the energy sources we have available to us, and these are the types of energy that these energy sources have. Now it's interesting to note that a lot of our energy sources, most of our energy sources, actually originate from one main source, and that main source is the sun. Food from the sun, coal from the sun, natural gas from the sun, wind power from the sun, hydroelectric power from the sun as well. But how does the energy get from the sun into a fish, for example, that we eat? And we can use a flowchart to follow these energy transfers. So, solar-powered food. Let's have a look. So the sun's energy beats down on the earth and gives us solar energy, falls onto the ocean, and through photosynthesis, algae grows and gains chemical potential energy. Zooplankton, the smallest little animals in the ocean, eat the algae, and they get that chemical potential energy into their little bodies. Small fish, sprats, for example, eat the zooplankton, and again, then the chemical energy passes into their bodies. And finally, salmon eat those sprats, and the chemical potential energy passes into their bodies. And then we eat the salmon. But not all of the energy from the algae reaches the salmon, as each organism uses energy to actually survive. So energy is wasted, if you like, along the way. Many other sources, as I mentioned, are also solar-powered as well. So after food, let's look at maybe our second most useful source of energy, and that might be electricity. But firstly, electricity is not really a source, even though we use it like a source. You just plug in your electrical devices into the wall socket and they work. Electrical energy is actually a type of energy that has been converted from various sources of energy. Let's look at electricity from wind power. So from wind power, wind, moving air, has kinetic energy. Through wind turbines, the turbines take out some of the kinetic energy from the wind, and the wind turbines start turning, so they also have kinetic energy. And then up at the top, behind the turbines, we have an electrical generator, which turns the movement into electricity. There will be some friction, so some energy will be wasted as well. Let's look at another one, electricity generated from coal. So the coal is burnt. Coal has chemical potential energy. When it's burnt, heat is released. The heat is used to heat up water to generate steam. The high pressure steam blows out very high speed and turns a steam turbine, which has kinetic energy. And then that kinetic energy is turned into electrical energy in a generator. So we can see the flow here, and we can also see at each transfer, heat is going to be lost. So not all of the chemical potential energy from the coal goes into the electrical energy out of the generator. In fact, possibly only 40%, 4/10 if you like, will be produced as electricity. And the rest will be wasted as heat. So we can use this flowchart technique to visualize how we use other energy types as well. For example, a car. So we can see the pictures here to help you, but try putting the words in place there. Write down where the energy is and the type of energy in each case. So give that one a go yourselves. So a little bit more on efficiency now. So I've said throughout the podcast that some energy is lost when work is done. Not all of the energy is transferred into a useful form of energy. Some of the energy that's transferred we could describe as wasted, as it's just not useful to us. An electric light bulb is a nice example. So we have an electric light bulb plugged into an electricity outlet. The electrical energy goes in, the light bulb gets hot, and as a result it gives out light. So the output is both heat and light. But because it's a light bulb, it's designed to give us light, the heat we could describe as wasted energy. So it's not 100% efficient. So efficiency is defined as the ratio of the useful output energy or power to the input energy or power. And there it is as an equation. So let's take a look at this example here. So we have a solar panel. The solar power, the amount of power from the sun at the Earth's surface, let's say is 150 watts per meter squared. 150 watts for every meter squared of the Earth. Now the output from this solar panel is 24 watts per meter squared, the electricity coming out. So we have the solar energy going in, 150 watts per meter squared, and the output 24 watts per meter squared. Efficiency is output over input. So let's do the calculation. 24 over 150. 24 divided by 150 equals 0.16. So 24 over 150 equals 0.16. Now we can times that by 100 to give us our percentage efficiency. So times that by 100 and we have 16% efficient. So solar panels are around about 16% efficient, which means 84% of the solar energy hitting the solar panels is wasted as heat. This doesn't sound very efficient, but don't forget the sun's energy is actually free. So in summary, energy is available to us from different sources and in different forms. Energy can be transferred from one form to another, but in doing so, some of the energy is wasted. This leads to efficiency, and efficiency is a measure of the amount of energy wasted, and we can calculate it by looking at the useful output energy divided by the total input energy.